Black holes are terrifying. They trap everything, light, matter, even time itself. But scientists think something could exist that is far worse. Something that doesn't pull things in, but rather forces everything out. It's called a white hole, the complete opposite of a black hole. But do they really exist? To answer this question, we first need to understand how a black hole works. So what are black holes? To truly understand the light-eating monsters of our universe, imagine a massive star dying. As it runs out of fuel, it collapses under its own gravity, crushing its entire mass into a single point of infinite density called singularity. Surrounding this point is the event horizon, the ultimate point of no return. Once you cross this line, the laws of physics as we know them begin to shatter. Space and time swap roles, and your only future is a direct path to the center. For decades, we viewed black holes as cosmic dead ends. But Einstein's equations of general relativity have a strange property: they are mathematically reversible. If you take the math of a black hole and run the film in reverse, the equations don't break. Instead, they describe a mirror image, a sphere that doesn't swallow everything, but violently spits everything out. If a black hole is a bottomless pit where time ends, then its mathematical twin must be a fountain where time begins. This reverse black hole is what we call a white hole. But what exactly is a white hole? And how can something exist if nothing can ever get inside it? A white hole is the theoretical twin of the black hole, born purely from mathematics. If a black hole is the ultimate cosmic prison, a white hole is the ultimate escape hatch. Nothing can stay inside a white hole, and nothing can ever enter it from the outside. Imagine the Big Bang, that explosive moment when everything erupted from a single point. A white hole is like a miniature, continuous Big Bang, constantly pushing matter, energy, and even light away from it at incredible speeds. It's a region of spacetime that is fundamentally allergic to matter. Everything is forced outwards. But this is where theory clashes with reality. The math says they should exist, but our telescopes tell a different story. We have mapped countless black holes, but we have never ever found a white hole. But why? The math behind white holes is solid, but the universe doesn't always follow the math. There is one major reason we've never seen a white hole: the second law of thermodynamics. This law states that entropy, or disorder, in the universe must always increase. A black hole takes highly organized matter like a star and crushes it into chaos, which fits the law perfectly. But a white hole does the opposite. It takes chaos and spits out organized matter and light. It's like watching a broken glass spontaneously reassemble itself. It's mathematically possible if you reverse time, but it's physically impossible in the world we live in. Theory suggests that if even a single grain of dust were to fall toward a white hole, the energy and collision would be so cataclysmic that it would instantly collapse into a black hole. It seems the universe itself is trying to prevent them from ever existing. And yet, the math refuses to go away. So, are white holes real, or just a ghost in Einstein's equations? We may never know for sure. They sit at the very edge of what is possible, mocking our understanding of how the universe works. If they do exist, they represent a bridge to a place we can never visit, or perhaps, a doorway from a past we can never return to. They remind us that the deeper we look into the cosmos, the more we realize that reality is far stranger than fiction. For now, white holes remain a beautiful, terrifying mystery, a reminder that in a universe this vast, the only thing we know for certain is how much we have yet to discover. Click on the video to hear how they sound.